Hi everyone. So yesterday we talked about solving quadratic equations by completing the square, and you can absolutely solve quadratic equations that way, but it can be a bit of a lengthy process. And so what we're going to do today is we are going to solve this quadratic equation, where we don't actually have specific numbers for A, B, and C, and try and get an expression for the value of x in terms of A, B, and C, so that we can plug in whatever A, B, and C values we have for our specific quadratic equation and use that to solve any quadratic equation, okay? And then that makes things really simple. Then we don't have to go through that process every single time of completing the square, and then things become much more efficient, okay? So what we're gonna do is we're gonna do a bunch of algebra to essentially take steps to isolate x from this equation, okay? And in this equation, we're gonna assume that A, B, and C are numbers. Now, this is going to become, there's gonna be lots of algebra in here, and it may get a little bit abstract because although A, B, and C are numbers, we don't actually know what those numbers are. So while I'm doing this, isolating x from this equation, I'm going to simultaneously do a numerical example. Okay, so let's say we're doing 2x squared plus 5x plus 1 equals 0. Okay, so in this scenario, a is the coefficient of x squared, so a is 2. B is the coefficient of x, so b is 5. And c is the constant, so c is 1. Okay, so the process of isolating x is exactly the same as what we did yesterday, which was we completed the square, okay? So the first thing we had to do is we had to factor the a value, the coefficient of x squared, out of the first two terms, which were the x squared term and the x term. So that's what we're gonna do. So we're gonna take out the a, and what we're gonna be left with here is x squared. Now, to take out an a here, I actually have to divide this by a. Because if you imagine going the other way, if I distributed this back in, a times b over a is equal to b. So if I go the other way, I would end up with what I started with. Okay, now numerically, what I would do is I'd take out the 2, and I'd have x squared plus, well, when I factor 2 out of 5, I have 5 over 2, right? Because 2 times 5 over 2 is 5. Okay, now what I have to do is I have to complete the square inside this bracket. So I have to take half of the coefficient of x. Well, half of that, I'm going to do this up here, b over a times a half is b over 2a, okay? When I square that, I get b squared over 4a squared, right? Because 2a times 2a is 4a squared, okay? Over here, 5 over 2 times a half is 5 over 4. So 5 over 4 squared, right, would be 25 over 16. So that's sort of the magic number that I have to add and subtract within the brackets to complete the square. Okay, so that's what I'm going to do next. So a times x squared plus b over ax, and then on this side, it's going to be plus b squared over 4a squared minus b squared over 4a squared, bracket, plus c equals 0. And on this side, it's going to be 2 times x squared plus 5 over 2x plus 25 over 16 minus 25 over 16 plus 1 equals 0. okay? The next thing I have to do is I have to take this the last term outside of the brackets, okay? So I'm going to do that next. So I'm going to have a times x squared plus b over ax plus b squared over 4a squared, okay? Now remember, when you take it out, you're also multiplying it by this a on the outside. So minus b squared over 4a squared times a, because I have to distribute that by the a on the outside of the bracket, plus c equals 0. Maybe I'll put a line down here so that we can separate the two sides. And here I have 2 times x squared plus 5 over 2x plus 25 over 16. And then here I need to multiply the minus 25 over 16 by this 2. Plus 1 equals 0. Okay, now what's going to happen is there's going to be some canceling that I can do with this term that I removed from the brackets, because a in the numerator cancels with one of the a's in the denominator. I've got a squared in the denominator and an a in the numerator. So I can simplify that. And if you look over here on the right side, 2, I've got a factor of 2 here, and I've got 16 in the denominator here. So I'm going to simplify that. So I'm going to have a, and in fact, now I'll write this as a perfect square trinomial as well. So this becomes x plus b over 2a squared. And then here I can cancel a factor of a. So minus b squared over 4a plus c equals 0. And I'll complete the square here. I'll write this as a perfect square trinomial. So this is going to be 2 times x plus 5 over 4 squared. And then the 2 and the 16, a factor of 2 cancels. So this is going to be minus 25 over 8 plus 1 equals 0. Okay, and now what I'm going to do is I'm going to bring these terms, right, the b squared over 4a plus c, or the minus b squared over 4a plus c, and then negative 25 over 8 plus 1 over to the other side. Okay, so a times x plus b squared, or b over 2a rather, squared, equals, now the signs will change, right, because I have to like add and subtract them. So b squared over 4a plus c. And this will become 2 times x plus 5 over 4 squared equals 25 over 8 minus 1. And the other thing that I want to do now is, and I'll do this actually on the right-hand side first so you can get a sense of what's happening here, is this 25 over 8 minus 1, I want to sort of write those with a common denominator. So right now this is 1 over 1. The common denominator between 8 and 1 is 8. So I need to multiply this by 8 over 8. So this is going to become 25 minus 8, 25 over 8 minus 8 over 8. And then on the next line, I'll be able to write that as using a common denominator. Okay? Here on this side, this guy is c over 1. So between 4a and 1, the common denominator is 4a. So I need to multiply this by 4a over 4a to get a common denominator of 4a. Okay, so on my next line, what I'm going to have on the left side of each equation, nothing's going to change. I still have a times x plus b over 2a squared. Okay, but here I have this common denominator now of 4a because both of the denominators are 4a. In the numerator, I have b squared and then plus c times 4a. So that's 4 times ac, right? Because you can rearrange the order when you're multiplying all those terms together. Okay, this should be a 1. I don't know why it looks like a... Oh, I'm sorry. That should be a minus because I brought that over to the other side, right? Minus. My bad. So from this step going down here should be b squared minus c. That's better. minus 4ac, my bad. Okay, that's why this one's a negative 2. Okay, now on this side, 2 times x plus 5 over 4 squared equals, now this is also all over 8. And now 25 over 8 minus 8 over 8, the denominator is 8, 25 minus 8 is 17 over 8. Okay, now what I'm going to do is I want to isolate this perfect square trinomial. So I've got to divide both sides by a on this side. And on the right side, with the numerical example, I've got to divide both sides by 2. So what I'm going to do to make things a little easier for myself is I'm just instead going to multiply by 1 over a. Okay, and here maybe I'll multiply by, running out of room, 1 over 2. Okay, because then it's easy to do this sort of fraction multiplication. Okay, so 1 over a times a, that just cancels. That's what I want. 1 over 2 times 2 cancels as well. Okay, so on the left-hand side, I have x plus b over 2a squared equals, here I have b squared minus 4ac over, now 4a times a is 4a squared. Okay, and on this side, I have x plus 5 over 4 squared equals 17 over 8 times 2 is 16. Okay, now the next thing that I want to do is I want to take the square root of both sides. Okay, so I'll take the square root of both sides. On the left side, I'm going to have x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. And on this, in this equation, I'm going to have x plus 5 over 4 equals plus or minus the square root of 17 over 16. Okay. Now, what's nice is if you look at the denominators in each of the radicands, those are both perfect squares. So I can actually take those outside of the radicands. So I'm going to end up with this. X plus b over 2a equals plus or minus the square root of b squared minus 4ac over the square root of 4a squared is 2a. And here I'm going to have x plus 5 over 4 equals plus or minus the square root of 17 over the square root of 16 is 4. Okay, and then the only thing left to do is subtract this b over 2a from this side, or in the other equation, subtract 5 over 4 from this side. So when I subtract that from both sides, I'm going to have x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And here I'm going to have x equals negative 5 over 4 plus or minus the square root of 17 over 4. And what you also may notice is that the denominators are the same. So I can write this using a common denominator. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we have now isolated x, and this is the quadratic formula. And so for every quadratic equation, you can now identify the values of a, b, and c, and plug those values into this equation to solve the equation. Okay, so here, again, we could write x equals negative 5 plus or minus the square root of 17 over 4. So this gives you two answers. X could be negative 5 plus the square root of 17 over 4, or x could be negative 5 minus the square root of 17 over 4. Okay, so let's see how this works. for example, if we are solving this equation, we need to identify what is the value of A, B, and C. Okay, so A is 2, B is -3, C is 1. Our quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And now we have to do a substitution, or many substitutions in fact. And I always recommend sub brackets in for these a, b's, and c's first, and then put the values into the brackets. So negative bracket plus or minus the square root of bracket squared minus 4 bracket over 2 bracket. Okay, and then for b, I'm going to put in -3 plus or minus the square root of b squared, so -3 squared minus 4 times a times c all over 2a. Okay, because one thing that people often do with the quadratic formula is make substitution errors. Okay, so now we just have to do some evaluation. So -3 is +3 plus or minus the square root of 3 squared is 9 minus 4 times 2 times 1 is 8 all over 4. Okay, so that's going to be 3 plus or minus 9 minus 8 is 1. So the square root of 1 is 1. So this is going to be 3 plus or minus 1 over 4. Okay, that gives us two solutions. X equals 3 plus 1 over 4, which is 4 over 4, which is 1. Or x equals 3 minus 1 over 4, which is 2 over 4, which is a half. Okay, so that's two solutions. Now, one thing to note about these two solutions is that they are rational. Okay, if you get rational solutions, what that means is that you could also have solved this equation by factoring. Okay, so in fact, I can tell from the answers, from the solutions, how this would factor. This is going to factor into x minus 1 times 2x minus 1 equals 0. Okay, so that's how this particular trinomial, 2x squared minus 3x plus 1, would factor. And from there, you can get the same answers. Okay? All right, so let's try a couple more. Solve x squared minus 5x plus 10 equals 0. So again, my value of a is 1, b is -5, c is 10. So I'll write out my quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And by the way, this is on your formula sheet, so you don't need to memorize it. And I'm going to do my substitution. And again, I like to put in brackets first so that I don't make any substitution errors, or at least I minimizes my substitution errors. Okay, and then I'll put in all of the values that I need. Oh, I forgot to put a squared there. That's better. Minus 4ac all over 2a. That's better. Okay. So -5 is 5 plus or minus the square root of 5 squared is 25 minus 4 times 1 times 10 is 40 all over 2. And this is 5 plus or minus the square root of -15 over 2. Okay. We have a problem here because we can't take the square root of a negative number. Okay, so what does this mean? This means that this equation does not have solutions. Okay, so graphically, we saw what that looks like graphically, right? Graphically, it's not going to have any x-intercepts, so it's probably going to look something like that. Okay, it's not going to have any x-intercepts. Okay, so using the quadratic formula, if you have a negative or a negative radicand, right? If the value of the radicand is negative, that tells you that you have no solutions, because this is, it's actually called an imaginary number, but we can't define that value. Okay, it doesn't make any sense. Okay, we're going to do one more. Here we go. X squared plus 8x plus 16 equals 0. So again, our values of A, B, and C, we'll write those down first. So A is 1, B is 8, C is 16. And write out our quadratic formula, x equals minus b, plus or minus the square root of b squared minus 4ac, all over 2a. And do some substitutions here. Whoops, 2a, there we go. And I'm going to put in my b value, 8b squared minus 4ac all over 2a. Here we go. And now I'll evaluate. So negative 8 plus or minus the square root of 8 squared is 64, minus 4 times 1 times 16 is 64, all over 2. Okay, well, 64 minus 64 is 0. So the square root of 0 is 0. So this radical part just disappears. That means x is just going to equal negative 8 over 2, which is negative 4. Okay, so we only get one solution. Okay, graphically, remember that looks like if we were to graph the corresponding function to this equation, then the vertex would be on the x-axis. Here would be negative 4, and it would just touch like that. Okay, so that would be the one solution right there. Okay, now what's an easy way to tell how many solutions you're going to get? What we can do is look at the value of the radicand. The radicand is the number that's inside the radical, and that has a special name. It's called the discriminant. Okay, so look at the value of the discriminant. And the discriminant is the b squared minus 4ac. Okay? If b squared minus 4ac is positive, then you will get 2 real roots or solutions. They can be called roots or solutions, okay? Now, the reason we use the word real is because of the fact that when you take the square root of a negative number, there's a whole branch of mathematics that actually looks at those numbers. They're called imaginary numbers. It's a bit beyond the scope of this course because typically you only look at those when you get into about a 3rd or 4th year mathematics course in university. But there are other numbers that exist outside the real numbers, which are the ones that we typically look at in high school, called imaginary numbers. So the roots that we will have to these equations are all real. Okay, so that's why we use the word real there. Okay, so if this value is positive, we are going to have 2 real roots. If b squared minus 4ac is negative, is less than 0, we're not going to have any real roots, right? Because that we can't take the square root of a negative number. And if b squared minus 4ac equals 0, we're going to have one real root. Okay? So that's a nice algebraic way to tell how many roots you will have to a quadratic equation without having to graph the corresponding function. Okay, now we have now looked at 4 different ways of solving quadratic equations. So I just kind of want to talk about the pros and cons of each because, you know, when you're sort of in the field just solving problems, you just use whichever is most efficient for you. Okay, so first thing we looked at was graphing. We graphed the corresponding function and looked for the x-intercepts or the zeros. Now, this is quick, it's easy. So that's good. However, it's not algebraic. So if you're asked to solve something algebraically, you cannot use this method. And it does not give exact values. Okay, it only gives you approximate values. So if you have to give exact values where you don't want to round anything, then this is not going to work. Okay, so that's one method. The other 3 are all algebraic. So if you're asked to solve something algebraically, those are all fine. Second one was factoring. Okay, now if you're good at factoring, this is really fast. And my guess is that, you know, the more math courses you take, the more you will rely on this method because you will do a lot of factoring to get good at it. Okay, so this is quick if you're good at factoring. Okay, it's algebraic. Okay, the problem is though it doesn't always work. Right? It only works if you have rational solutions. If you have an answer or solution that is irrational, it means you can't factor that trinomial, and then this method won't work for you. Okay? So the third thing we looked at was completing the square. Okay? So to be honest, this isn't really used in practice. The reason why we get you to do this is so that you can understand the quadratic formula, right? Because the quadratic formula is derived by completing the square, but you can absolutely solve a quadratic equation by doing this. It always works. And it's algebraic. It gives exact values. So that's all good. But it takes a long time. It's really lengthy. Okay, so that's kind of a negative for that. And then finally, today we looked at the quadratic formula. Okay, so this always works. Okay, it's relatively quick and easy. Okay, and it gives exact values. The one thing that I will caution you about with the quadratic formula is that people often make careless mistakes with substitution. So watch out for that. Okay, so these are the 4 methods that we looked at. Make sure that you're paying attention to instructions because you may be asked to use one specifically, or you may be asked to solve something algebraically or give exact values. But if you're not, then everything is up for grabs. All right, so I'm going to leave things off here, and I will see you guys.